Hello, everyone. Welcome to another edition of the Subseasonal Forecast Contest. My name is Dan Margolin. Today is February 23rd, so we're forecasting out to mid-March, March 10th, March 14th, still in HDDs. Let's see, for today, beyond our usual, attribution, talking about some of the recent forecasts, which have been obviously interesting to say the least. And today's forecast. Any other items that folks want to talk about today? Anything jump to mind? Snowstorms, teleconnections, anything like that? No?
Hey, Dave, I'll go.
Yeah, go. What's on your mind?
So I'm still I've drawn up a few kind of retrospectives for work, and I just share a little bit about kind of the stepping back, kind of admiring the magnitude at kind of what we witnessed in the middle of the country, for roughly 10 days. With regards to not just the intensity of it, but kind of the historical precedent. So that's the verification period, I think. But if you looked at a window that was like if you could do a window, Dave, from say the 11th or 12th through like the 18th, 12th through the 19th, it's just really remarkable magnitude of the cold. If you could do the anomalies, Dave, that's really more of just what I'm kind of interested. Yeah, that's just something that I've really not seen in my working career. You kind of have to go back to it outdid, or at least rivaled in many places, the outbreak of December '89, and then you have to before that go back to '83. I really, it's hard to fathom a -2 in Dallas, and then like 7 consecutive days below freezing, and then a 13 in Houston. And then obviously the amount of snow cover, really rivals anything you kind of can see in the historical database of the last half century. And we're doing it in a climate, we spend so much of our time, or have spent so much of our time talking about, the lack of sustained winter weather, the lack of extreme cold, the lack of really impressive blocking patterns. And then preceding this was, a really phenomenal negative AO for the first half of February that preceded this, the trough to dip into, there it is, with, bottomed out on like the 6th or 7th there, really a highly anomalous number. Just stepping back and admiring that, like the weather, even in a pattern or a series of winters, which don't seem to materialize much true winter weather, you can do this kind of an event. Continues to go back to this thing that I've been talking about for a long time, which is that we really underestimate the tales of what weather can deliver. And this week really exemplified that. We saw some numbers that we just didn't think we could see, or at least didn't really imagine very well as being a possibility, even a week out from the event. The fact that the models, particularly the GFS, did so well with this event is probably, to me, a large surprise, and something that'll probably get looked at a little bit more seriously. But not just that, but the inability for the European model inside of 10 days to really kind of not just get this event, but even show it consistently, because the volatility that we've been seeing with the European, going back to like the 3rd, 4th, and 5th of February, 8, 9, 10 days out from this event was really baffling. The fact that the European couldn't latch on to the consistent Arctic air signal. So it's really just a remarkable event that we've kind of just gone through. And I guess continues to show you that in even what seems like benign winters, this winter has been anything but benign across the hemisphere. And we could talk a lot about what the attributions to that are, but just the kind of how unprecedented this event has been in most people's lifetimes. To think that Texas hasn't witnessed an event similar to this since December of '89, and the population of the state has doubled roughly since around 1990. The human socioeconomic impact, and we've all seen the headlines with regards to like power outages and and then the manifestations of what happens with that, with pipes bursting and infrastructure failing and all that. And I don't want to litigate that, or I don't mean to like get into the politics behind that, but from a pure weather standpoint, it's really pretty remarkable. And I think bears witness to this idea that, you still get extreme events, and that has a major impact on life and property.
Yeah, thanks. Yeah, I wonder, I mean, it's such an important event. Maybe we could just, if everyone's okay, we could spend some time on it. And, I'm curious, again, we'll keep the politics out of it, right? But I'm curious, just from a couple angles on it that maybe we can dabble into. One is just, yeah, the traditional sort of some of the things you said, the pattern drivers, and talking about the differences in performance from the EC and CFS, or GFS, or American and European guidance. I think that's really interesting what you said there. And is there anything else? I know you and we haven't all had a lot of time to explore it from a research angle, but it'd be interesting just to throw out some theories in terms of why one model did better than the other. I also think I heard some stuff on the news. Yeah, uh, regarding climate change and these kinds of events, and whether it's linked or not. Again, keep your politics out, but just from what the research, from what we understand about climate change research, does anyone have an opinion on that in terms of that? Is this evidence of climate change, or is this just evidence that once maybe an event that you might have expected, a cold event every 20 years, now it's still going to occur, but it might be every 30 or 40 years or 50 years, but it doesn't mean it's not going to occur. And then also I am interested in just Dave, it's good having you on the line. Just what we can learn from what happened in Texas. Again, not the politics, but just things like for a lot of us who don't understand the energy infrastructure much, there's just general questions in terms of why things failed, and what things can be done in the future so that it doesn't happen again. Is it possible to mitigate this? Why does it happen here but not North Dakota? That kind of thing. Like, what's the difference? Is it less energy? Is it the infrastructure is not as well prepared? Is it transmission lines? I think Dave, you might be able to speak on some of those issues. So,
Sure.
yeah, go ahead.
You may go. Okay.
Yeah, if you don't mind. Yeah, go
I
ahead.
don't mean to hijack this just to make it like all Texas, hindcasting, but at a high level, Texas receives about 30 to 40% of its energy on a daily basis from solar and wind, well, predominantly wind. And what happened in this event, and I'm not making an argument that it was just the reason that we had power outages in Texas was a wind failure. So please don't conflate that. I think this is going to be something that'll have to get a more serious look back. And I've seen some very well thought out articles that said this wasn't a failure of wind. This was a failure to deliver gas to power plants when it was most critical. But let me just mention the wind part, because it is a component, but it may not be the component. From a wind standpoint, starting the week prior to the event, you had a freezing rain and actually freezing fog event around the 9th, 10th, and 11th. This was when the cold first started to creep into kind of North and West Texas. They were particularly wind sensitive areas. So wind began to fail early on in this event and was running, I'll just put it in terms of, we were only getting probably 40% of what was predicted, early in that week. And then when the true vortex came down, when the bulk of the high came down on the 13th, 14th, and 15th, that was met with a snow event, which further reduced the ability of wind turbines to operate. And so that when you get to the core of the event, which was like the 16th of February, which would have been a week ago today, you were getting, maybe 30% or 35% of total wind capacity, what you were used to. And just on a rough basis, we were losing, for every 10% you lose, you cut out kind of like 700,000 homes on a basis. So if it's roughly like 5 million homes could have been powered if we'd had wind at what was predicted capacity. But ultimately, though, you had gas that couldn't get delivered to not just homeowners, but you couldn't get gas to be delivered to infrastructure. Let me talk about wind for a second, though. When you get the freezing rain, you, like any mechanical device, you seize up key components of turbines. You ice over blades, you ice over the turbine housing, and any ability to operate at full capacity gets severely limited. And so you had compounding effects during that week, which is not just starting with the freezing rain event, but then the snow event was really the kind of the hammer on Sunday the 14th, which was at the leading edge to that deep Arctic air. From a gas production standpoint, you had multiple failures going on. One is that you have, and so the reason that doesn't happen, Dave, or the reason it happens more in Texas and less in like the upper Midwest, is that you can quote unquote winterize wind turbines. And it comes down to like the lubrication fluids you're using and kind of the components. And that hasn't largely been done in Texas, but one is that's a very expensive proposition. Right, like it goes to -10 every winter in North Dakota, but it doesn't go to -2 in Dallas every winter. So that becomes a cost-benefit analysis that is done at the wind farm level, which is like, do you protect for an event that is every 30 years? And I think there's a big ask there of getting meteorologists to be involved in that discussion. With regards to gas production, quote unquote, freezes off, we call it, when temperatures get very cold. And the reason for that is that a lot of the gas production is requiring water to be injected into the gas well to actually, you inject water to get gas to flow out. That's part of the process. And so when water at the surface freezes, or the fracking fluids, we call it, are less viscous, and you can't get gas to come out of the well as you would, or I don't know, just normal, mild weather circumstances. And so you lose gas production, and that's critical to powering not just homes and putting it in pipelines, but also to power plants to generate electricity. And it seems like that is becoming a focus as like a bigger concern than the wind itself. You also had failures at things like compressor stations. You had mechanical failures at pumping stations that can move gas through pipelines efficiently. And when you get temperatures that are extreme, when you get like a 3 or 4 standard deviation event in Texas, that, these kinds of things start to fail. The infrastructure failure is going to get looked at. Obviously it's going to get put under a microscope, and it'll be litigated, and there'll be legal consequences, there'll be legislative consequences, and that will take months or years to really play itself out. And the question will be, how much are meteorologists going to be involved in that? I will say this, I don't want to get into the forecast component of it. I think that, I'd rather leave that to you guys and talk about and, think about. But this is an interesting event because it highlights the need for really strong communication skills in the face of kind of just getting the numbers out, right? So like you might make a correct forecast, or you might be on the correct side of a forecast, but in real time, we can't lose sight of the fact that this really still needs to be a communication problem, or we needs to have a high level of communication between meteorologists and emergency managers, the public, end users in the gas and oil industry, healthcare, et cetera, particularly from an emergency management standpoint. You can make a comment of like, oh, it's possible to get down to 0 in Dallas, or it could get to the lower teens in Houston, but trying to wrap that around a larger discussion about the impact. You start to quickly deviate from, you can deliver the numbers and you might make a correct forecast, but if you can't communicate it well, stress the uncertainty, stress the historical precedent, what you might be experiencing, then I think that the numbers alone may not or can't tell the whole story. And thanks for giving me the floor, Dave. I didn't want to make that a long discussion, but thanks for giving me the opportunity to share some of that background about what happened and what unfolded.
No, I mean, I think it's worth it. I think it's worth to dedicate, a good part of this, if not all of it, to talking about this event in all aspects of it. So I know a couple folks joined during the discussion. I think they probably have a pretty good idea of what we're talking about. We're talking about the severe cold event that's impacted a good part of the country, but in particular, the middle part of the country, Texas in particular, and then some of the impacts that it's had on the infrastructure and on in particular energy supply to Texas. And Dave's just giving some perspective on that. Does anyone, before we maybe shift gears or talk about some other things related to this, does anyone have any follow-up questions for Dave?
So I joined late. This is Steve. So maybe this was discussed earlier and I missed it, but I'm curious how important was the lack of connectivity of the Texas grid to the rest of the country in terms of all this stuff fails in Texas, but if it was connected, maybe the power could have come in from winterized places or whatever and made up for it.
Sure, that's a great question. That was Zach, right?
It was Steve, actually.
Steve, I'm sorry, I apologize.
No problem.
That's a great question, and that's something that will get discussed. I will say that so to kind of give the overview of those who may not be familiar with what that is Texas. There's three grids in the United States. The grid that's largely the eastern half of the country, exception of Texas. Texas largely operates on its own grid, and then there's a grid which is for the western United States, which is roughly the Rockies West, which really from an energy standpoint is mostly just California. There's been a question, which is that if Texas was part of the larger grid in the eastern United States, could they have or would they have had the ability to draw power from locations outside of Texas to help mitigate some of the power losses in Texas? I don't have a short answer to that question. I will say that the history of Texas being part of its own grid is a very long history, which largely goes back to just the post-World War II era, when Texas was the only energy hub in the United States. So there was some early thought that Texas could be part of its own grid from a national security standpoint because it was the only place that we were drawing oil from in the 40s and 50s. That's been kind of gone through multiple iterations. We've kind of deviated largely from that. And clearly we get energy from lots of places. We get from wind power in the Midwest, from, fracking oil and gas in the Appalachians and parts of the Northeast. I don't have a good answer that possibly the answer maybe is it could have helped Texas situation last week. But it is a challenge when it's, minus 14 in Oklahoma City, it's minus 20 in Omaha, and it's minus 5 in Chicago. It's not just as easy as say, can we draw power from those locations which have intensified demand for their own electricity and natural gas? So the short answer might be maybe, but it's something that will obviously be examined. It's likely that we'll see significant changes to this, what is Dave's putting up is the Texas Interconnect, if only to kind of, we're always really good at preparing for the last disaster, right? So the knee-jerk reaction would be say, well, if we just got rid of the Texas Interconnect, we could put them as part of the larger grid and maybe prevent a situation like this from happening. It may have helped some. I don't want to use strong words like it would have helped. I don't want to say with certainty because we don't know, but it is something that's worth looking at. And I'm glad you brought that up because it's something that will get examined as part of the larger changes that come from a situation where, you have 5 million people without power for a week under extreme cold circumstances. Clearly no one wants that to happen. And maybe that's Texas Interconnect is something that has to not just go away, but maybe change materially.
Thanks.
It's not a great answer because I don't know. I can't speak to the intricacies of, how Texas being not part of the grid. So I want to make sure that I'm not an expert in just Texas Texas's grid, how it may have gotten tied in better to the rest of the world.
Okay, thanks for the insight.
Any other questions for Dave? Okay. I guess, and if other questions come up, just jump. You can just shout them out, because again, I think this is an important discussion. But I guess we can. I am just before we completely switch gears. I had one other, and you can feel free to pass on this. But and again, this is not keeping politics out of it. But I did hear some discussion about climate change related to this. And Dave, as much as you want to share, do you have any opinion based on your knowledge? I know climate change is a little bit different than operational forecasting and whatnot, but how this event ties in, if any, in terms of climate change. Do you think the research that you've seen, that it can be at least in part explained by it, or do you think it's actually what's the word? I don't know if red herring's the right way to put it, but just that it's not necessarily just you're still going to get cold events, just maybe not as frequently, and you got to be cautious about just tying any kind of extreme event into climate change. Do you have any thoughts on to how this event, kind of where it fits into things?
I do. It may make us rethink the possibility of how kind of distributionally extreme events look. We may rethink if we thought the possibility of an event like this was like extremely low to zero, we may have to rethink that. I don't have a great comment about how it fits in the larger context of climate change. We've looked at this, David, you and I've been part of some research projects that have looked at, extreme cold events, and the less how infrequently they were happening, over the course of the last 3 decades. And we were tying it to things like, we don't see 1070 Arctic highs coming out of Northwest Canada with the frequency that we used to. We don't see blocking events like we used to. And then, of course, this winter, we see this -6 AO event in February, and it kind of makes you rethink. I'm not sure how we'll end up kind of examining that going forward. I know for how we apply it, it will become part of the discussion of events going forward. It will have to be, we'll have to catalog that and include this as a risk. I don't know. I'm kind of making a big sigh here, because we're kind of just, we just saw the event last week, and we're barely in the start of like doing a where does it fit in the context, and obviously there's still impacts that are going forward, and I don't know. I think it's going to have to be included, as obviously it's in the data set now, and I think it's obviously you'd have to be to attribute, like, say that, well, there's no chance we're going to see that again, obviously is probably too short-sighted. But I don't want to conflate it and think now that, like, oh, just because it happened once, it somehow has some, I don't want to over ascribe the possibility of that event happening, in the near future. But I'm a little bit probably ill-equipped to answer that in my role right now.
I mean, I can maybe offer some perspective if you'd like.
Yeah, please. And by the way, Nat, just this is Nat Johnson who's talking. I just pulled up a page real quick. This was a link that someone provided on the SUNY Albany list. It's a weather list thread from that's again part of University of Albany. A lot of meteorologists partake in it. I thought it was an interesting website. I haven't explored too much, but this chart in particular is showing you the change in frequency of high and low temperatures across the country. But yeah, Nat, please, what are your thoughts?
Well, it's from my experience in the climate research world, yeah. So there has been sort of a kind of a vocal group that has advocated for the possibility that Arctic warming or more specifically sea ice loss. You know, some of the main proponents, Judah Cohen, Jennifer Francis, that these sorts of these changes in the Arctic have led to slowing down of the jet stream, which leads to a wavier, more more frequent, high amplified ridges and troughs. That would be conducive for extreme, more extreme cold, even with an overall general warming pattern. So and of course this is very hotly debated. So I would not say a consensus view, but I think some of their support was besides some just kind of basic theoretical arguments, which not fully. I don't think all the connections made, but also if you looked at say temperature trends over over land in the wintertime, in the northern hemisphere, there was a period of time when there was a drop, and it's most pronounced over Eurasia, but also parts of North America as well. So it seemed like the wintertime temperatures weren't rising, although that seems to have been reversed in recent years overall. And there are some model studies that give some support in some way. So like studies where response to reduced sea ice in like the Barents-Kara seas, you can see in some experiments some cooling, but it's I think more robust over like Eurasia than it is over North America. But there's other, but if you look at these, at most climate models, they don't predict more extreme cold. And in fact, they kind of would predict the opposite. So if you're warming the Arctic more than the mid latitudes, then you're reducing that temperature gradient. So you expect less frequent intrusions of cold. So I'd say at this point, the consensus view would be that this was a weather event, and and even though extreme cold is becoming less frequent in time, we still do get extreme events. We're still going to get it, just going to be less frequent. But there is still a research question about whether or not that we do see it could be more wavier jet stream in some regions in response to changes that are occurring in the Arctic. But it's I'd say at this point being investigated, but it's not on really solid footing at this point. But that's my perspective.
And hey, Nat, and I guess this is for Dave too, but let's see. Let me go to a different page here real quick. Is it fair to say, we always try to, in these discussions, talk about, possible avenues for research for our, for folks who are participating in the contest and such. Is it fair to say that, the wavy behavior you're describing can be proxied at least in part by the Arctic Oscillation? I think the amount of blocking, right? I think.
Yeah.
Okay. Yeah. And I was in layman's terms. This is not the PhD. This is the the operational meteorologist Dave. But I think I've heard some of the research that Nat's offering too. And it's the idea is that you know, the folks who argue that, hey, maybe the frequency of extreme cold events will stay the same, or I don't know, maybe even increase or at least decrease less than the entire curve, is because like Nat was going to, it's like, hey, the frequency of Arctic blocking will increase such that it will offset, so that you just won't get the entire curve to shift warmer. The lower end, the colder end may stay, as frequent or whatever. And if that's the case, right, we should be able to measure that by looking at the AO trends, right? They're looking at the AO. So everyone here, we've talked about this many times, right? Everyone here has access to, the AO daily and monthly data back to 1950, right? You just go to the CPC, you just Google literally CPC AO, and you get there, and you have the links right here, download daily data, and you get it, right? So, I certainly encourage, if anyone here on the line wants to look into that and such. And I can tell you, and I haven't done this in a while, but when I've looked at this, and of course, meteorologists like Dave and I are looking at this anyway, because regardless of climate change, we just want to know, is the frequency of AO going up, down, because it can be associated with, obviously cold and warm events in the United States. And and when I've looked at that, I have not seen a significant trend. So then it comes back to understanding, and asking, it would be great, who knows, maybe we could even have some of these folks, like, if we're not seeing a trend in Arctic blocking, then, what other indices, proxies can you, or should we be looking at to help describe this phenomena? And if we can't find them, if they don't exist, why don't they? And does that suggest that maybe, that relationship is not as strong as maybe we thought when some of that research came out? Nat, I want to give you a chance. I know I threw a lot of stuff out there. Any comments in terms of what I just mentioned?
Oh, sorry. Yeah, I was muted. Sounds like a yeah, good idea. Yeah, I mean, there is a lot of data available. That's free to analyze. So and there's probably creative ways to address it. So just I think just looking at trends, you might not see much, but maybe looking at variability, or getting into some of the higher moment stuff. So creative ways to look at the data. I think it's possible there are new insights. So of course, one of the challenges with an index like the AO is that it's very noisy. So it's hard to determine like significant changes over a long period of time. Even if you have 70 years of data, it still can be challenging to determine significant changes. But maybe you look at you can aggregate the data in different ways and dissect it in different ways, and there's things possible that can tease out some interesting things.
No, that sounds good too, and right, and I like the way kind of Nat put it too. You could see I was almost less of my research meteorologist hat on. I almost like leading in a certain direction, but you should be very skeptical. You should go into it not necessarily thinking one hypothesis better than the other. You should try to crack it from all different angles, not assume anything. Hey, maybe there's another index other than the AO that, even if the AO doesn't show a trend, maybe the NAO would, right? Maybe it's more regionalized, but hey, that could still be important, or some other index. So I like the way Nat put it. And I just want to say one other thing here too, again, to emphasize for folks who could be in the seat that Dave and I have often been in the last 15 years, when we're when you have an extreme event, and then after an extreme event, of course, everyone's hair is on fire and they're always looking for solutions. And it can be a very difficult situation, highly stressful and stuff. And the more you have data and research to back up your conclusions, the better. So, if someone comes to Dave, for example, right now and says, oh my God, I saw on the news, like, these events are going to be increasing because what we just said, like the AO is increasing and blah, blah, blah. It's really helpful, right? if Dave and I, or if it's some of the students here in the future, you're able to do some of these research exercises on your own, right? To be able to look back and say, you know what, I was able to look into this, and actually, we do not see, let's say that was the conclusion. It may not be, but let's say the conclusion was you didn't find anything. I was able to investigate this problem in two different ways. I looked at different metrics that describe blocking. We did not see a trend. I looked at different metrics that describe the chart I had up before, which is, the frequency of extreme events. I did not see that before. So based on the information I've seen, I attribute this to the fact that you're still going to get 1 in 10 year cold events in Houston. You're still going to get 1 in 50 year cold events in Houston. The difference is they're going to be we're going to call the 1 in 10 a 1 in 20, and we're going to call the 1 in 50 a 1 in 70 or something like that. I think having the data and the research to back you up, it's going to make you more confident, more decisive, and I think ultimately going to help the folks who are the decision makers, right? The folks who you're providing your guidance to. I don't know, Dave, if you have any thoughts on that too. I mean, that's just my 2 cents.
I think that's great, Dave. For anyone on here who's a student or will be moving into the workforce, in the near future, thinking about positioning this, 2 ways. One is that the high level, I don't want to say high level because it kind of maybe makes it seem less, but the macro view of the likelihood of events from like long time series analysis of not just the AO, but like Dave suggested, maybe other indices, is different from kind of managing the event in real time in forecast space, like we do here with the subseasonal forecast, right? So starting 3 or 4 weeks out, looking at things like indices and trends of models and European weeklies and recurring Rosby wave train. We've had some discussion of that here the last few weeks. Any number of parameters to look at for the event, right? Those are 2 different pieces, right? One is kind of you always think about it in terms of like a pre-season look, which is what is the possibility of X happening given some long-term trend, and then kind of like intra-seasonal stuff. And they're both very interesting, and they both have a very big component, and they do tend to play off each other. So the ability to kind of discuss your competency with both of those things is pretty important. Right. This also points out to not just the ability to kind of look at things from a macro perspective, but the ability to kind of ride the waves of modeling deficiencies kind of leading into real-time events. There's going to be a tremendous amount, or there already has been a lot of Monday morning quarterbacking of this wasn't a failure of weather forecasts or weather forecast did great. And I tend to shy away from that because, if you're sitting there in Houston without power, nobody really wants to hear about how it was a great weather forecast. And I like to think that we just take a little step back, talk about the historical precedent of the event, and then let's talk about the analysis like at some further time. And there's been an awful lot of like really quick to jump in and defend weather and meteorology, and whether it did well or whether we had great forecasts or not so great forecasts, that is definitely left to be discerned perhaps by the end users, not the meteorologists themselves.
Yeah,
that's another story for another time. I don't want to go on that soapbox.
All right. Well, I guess this probably is a good time to shift gears. We only have 15 minutes left or so. So let's look back. Let's actually get into our synoptics a little bit. And maybe I'll let I think Michael's on the line. Maybe I'll let Michael kind of open up here in a second, just talk about the forecast, any interesting things he said or saw on this. Let's see, so I just want to go back to the most recent verification. So where am I? Week before this, right? All right, so this is our most recent verification. It verified at 174. Let's just pull up the maps here. So this is the 17th to 21st. I want to pull up okay, that's about right. It doesn't match exactly. That's about right. And let's get the Dynacast too, so that we can just compare. And I know obviously this is not the first wave of the cold, but we did talk about that last week. So I don't want to just go back to the first wave, which is interesting, of course, in itself. But Um, all right, so let's go to that's the temperature outlook or the temperature anomalies. But let's pull up the upper air kind of thing. So this is 17th to the 21st, right? All right, 17th to the 21st. There's your 500 millibar pattern. Really, God, interesting. And then here is your EC again, and here is the CFS. Let me just do a quick scan here, just for so everyone can see. So, or like, let's look at the benchmarks. So the verification was about 175. It's at the bottom, 175, 175 HDDs, right? Pretty darn high. Just to give a benchmark, 30 years, 135, the 10 years, 133. So, 40 or so HDDs over the 30 year. Where was the EC and the CFS? The EC, 141. CFS was 154, so much better. Of course, to Dave's point, there's a lot of, this is a snapshot in time, but when you're an operational meteorologist, you get multiple model runs per day, often, or at least per week. Um, so, and Matt Lanza looks like he was the big winner here at 155, although still 20 HDDs below. So one thing that jumps out is, certainly from the 16 to 20 day, the CFS, Dave talked about this earlier. Dr. Decker's talked about it, who's on the line all winter. Interesting, another case where the CFS, by hook or by crook, performed better than the EC. But let me stop there for a sec, because Dave and I've been doing a lot of talking. Michael, I think you're on the line here.
Yes.
Anything here that jumps out to you, or things that you want to talk about in terms of this forecast or some of the recent forecasts?
The only thing that kind of jumps out to me is how well the CFS has performed. I think it's been performing well overall this winter. At least better than the EC if that held. Yeah, it looks like it has. I think that's a little bit surprising considering, the CFS has been kind of a joke, at least in the forecast contest, since I've been here.
Yeah, I'll just say I just jumped. This is my first week back in a while, and so I have been out of touch. So that was one of the first things I checked, and I was kind of shocked to see the CFS at the top.
Yeah, and it's not a trivial amount of forecast, right? I mean, the sample size here, it's not a million, but it's 18, right? It's not like, I remember when Dr. Decker brought this up the first, earlier in the winter, and it was kind of like, well, we got a long winter to go here. We got a long while to go, and but it's held up. It's held up so far. Yeah, anything else? Any Michael? I mean, I know it's not an easy question, and this goes out to the rest of the group too. But we'll start with Michael. Anything in particular? Again, not an easy question. I don't have an answer really, but anything you've noticed in terms of the CFS this winter, or do you have any thoughts in terms of, do you think this is more just dumb luck? It's a good season, and that by the summer we'll go back to the normal kind of way of things, or is there something different? Maybe an upgrade, something. Is it anything jump to mind?
I personally, for sure, I don't know, but my suspicion isn't that it's dumb luck. It's more that whatever was in this pattern, the CFS was just particularly good at reading, and the Euro just straight up wasn't. That's my personal theory that about why the CFS did so well this winter as opposed to the EC.
That's an interesting idea. Can you expand on that? When you say pattern, do you mean, and I assume you're talking about the entire winter, right? Because it hasn't just been the last couple of weeks. Are you thinking like the climate signal, like La Nina, or or maybe even
Um,
just beyond that, like just something that we can't explain right now, but something about the oceanic atmospheric state?
yeah, I mean, I'm thinking kind of like, the La Nina combined with, the MJO combined with the um, polar vortex and the disruption and those kind of things. The model just handled that better is my 2 cents, because there's a lot of stuff in there and extremely complicated for the forecast models to kind of sift through all that and make a forecast that is even close to being decent. And I think the CFS just handled it better. I'm not sure, but I want to say the CFS was upgraded recently. So that might have something to do with it. I'm not 100% sure on that though.
Sorry, this is Steve. I'm not sure if the CFS has been upgraded, but I do know that GEFS was upgraded in the fall, a big upgrade. And I think the CFS is downstream of those. The analysis that the GEFS is coming up with feeds into the CFS, I think, eventually. So it may not be that the CFS itself is upgraded, but maybe its initial conditions are a lot better than they used to be. That's my theory, not knowing all the details of exactly how the CFS works. But I do know the GEFS was upgraded in the fall, and that's kind of seems to match the timing of when the CFS went from last place, basically, to suddenly being in first place.
Makes sense, actually.
So, I think that would be something that's very, as we think about things and how to the research method here, are these things that we can actually test, and that, that could be something you could test. The other thing that comes to mind here, and this is a question also for the other folks on the line, it's something we said last, something that Michael just said and was talked about a little bit last week. It seems like that would be a logical place to start, right? Like, go for the low hanging fruit. So I don't know, La Nina Bay State, right? Is there something there? So like, if we had the reforecast data or something like that, and we could, and these are all doable things, right? But like, that might be something you could look at, right? Just a very basic thing. How has the CFS performed historically in La Nina Bay States, right? As compared to the EC, does the differential change? Does the CFS perform better than usual in those situations? That would be a very basic thing to ask. And taking that one level further, and this is where I'm curious what Dave or Nat or some other folks think. But one thing, and this is where I'm speculating more. One thing I've noticed in the past, and I've seen some research to support this, but it's been a little while, that the EC had a significant bias in terms of producing too much anomalous ridging out in the Central Pacific, right? And almost like in a supercharged La Nina, right? Like it would put additional heights into like where you see some of the ridging here on this map. And I wonder, again, speculating, but and I would love to test this if could it be that was part of the problem with the EC this year, and that we already had a La Nina Bay State, so there was already in a lot of situations during the course of the winter, maybe a certain amount of ridging in this area, and then the EC put more ridging in this area, and it had the unintended consequence, especially when you're talking about like 15, 20 days out, not so much a day out, but long terms out, of anchoring that ridge artificially and making it harder for, not a very scientific word, but harder for the EC to capture pattern changes, making it slower to respond to pattern shifts that could have been, could be important, like even subtle shifts where the ridge, instead of being located here is located, 20 degrees or whatever it is, 2,000, 1,000 miles, 500 miles further east. You can see here in the verification, in some cases, doubles in the details. The ridge here is not that much further east, right, across the West Coast here, but it is a little bit further east, which allows a lot more cold to spill into important cities in the country. So anyway, that's just a thought. Any comments on that sort of hypothesis?
I can give some thoughts with my incomplete knowledge. Yeah, I think there could be something to it. From I haven't looked at the forecast for the last almost 2 months, but when I was making forecasts in December, I noted that the EC from day 16 onward, the forecast from week to week did not seem to be changing much. It seemed to be really dominated by the low frequency, La Nina signal. So that seemed to be really dominating. But what we've seen this year is that we haven't had a canonical La Nina pattern. So I think there's been like kind of a canonical La Nina bias in these, at least in the forecast I looked at. I don't know about if that's persisted. When in reality, we were seeing a different, more of a positive West Pacific pattern within the sort of the big ridge over the North Pacific like you typically see for La Nina. So maybe it was kind of stuck in that pattern and tough to respond to other other changes going on at this time scale. But I'll have to defer to others who looked at the forecasts a little bit later. And another thing I thought was interesting is CPC does some kind of real-time attribution, and they looking at the November through January circulation, and so they have some PowerPoint slides. And one thing I thought was interesting is they looked at the CFS forecast, the seasonal forecast, and they also did some AMIP runs, so where you just force the model with the observed SSTs. And what was interesting to me is that the AMIP runs actually did a pretty good job of getting the circulation, and they did much better with the temperatures over North America. But if you compare the AMIP to the seasonal forecast, both of them had the La Nina. The tropical precip looked very similar to me. So even though the SSTs and the precip, the tropical convection didn't look that different, the circulation was much different. So like what Dave said, the devil's in the details. It just brought to mind that there might have been some sensitivity to some very precise details for this winter. I don't understand what they were, but that was very curious to me.
Thanks, Nat. I know we only have a few minutes left. There's a lot of good nuggets there. We do, maybe for next time, we do have a spatial correlation chart that we can show. We've looked at that a couple times this winter, and I know the last time I updated it, looking at spatial correlations, 500 millibars this year versus some of the other La Nina events, it was extremely low. It was compared to like some of the other 2010. And I really like your point about I would love to see like, and this is kind of a question for Dave too, like a sensitivity analysis to say, like, are there certain patterns where the temperature forecast errors are going to be much more extreme just based on the pattern configuration? And because that, if a slight adjustment in the pattern can, with like a normal error, a normal type error in the 500 millibar pattern can cause a much bigger type change in the temperature distribution. And just understanding that better, I feel like as a meteorologist, I don't fully understand that. I would love like almost like a calendar of knowing, hey, this is a particularly dangerous or highly volatile kind of situation. But we have a few minutes left. I know we're not really going to get into the forecast much today. Actually, Michael, or let me see, who else? Philip, Philip, why don't I just turn it to you for a second here? You can finish this off. Let's shift to the forecast here. I know we haven't talked about it much, but give us your 2 cents here. So I'll be the end user. We've had this extreme cold fill up. I'm seeing some of the model data suggest that I'm gonna be the jerkish trader a little bit here too. I know Dave D'Arcangelo doesn't like this question, but like, hey, it looks like we're seeing a big shift here to warmer temperatures. Is winter over here? I mean, are we ever going to see any kind of more really significant cold like we've seen, or is whatever got us to the last couple of weeks likely not going to repeat itself? Philip, how would you address some of these easy questions?
All right. Well, I guess first question, is winter over? I think in terms of the extreme cold, it looks like the coldest era is now retreating, and it doesn't seem to me, just partly because of climatology also as we head into March, that the coldest of the coldest not likely to make a comeback, at least those really extreme cold temperatures. That said, there have been some signs. I haven't looked into it as much detail, but I did note people talking about the stratospheric warming and all that, suggesting that there could be a renewed push of somewhat colder air into the first 1 or 2 weeks of March. So although winter, in terms of the backbone of winter, seems like it's over, winter in terms of its effects looks like it may make some kind of a comeback as we head into the week 3, week 4 period, especially past beyond this week, I should say.
I thought that was a really good answer. You didn't, kudos, in my opinion. You didn't it's very easy to hesitate and hem and haw a lot with questions like that, but I felt like you gave me a pretty clear thing. Like, hey, I can see by your forecast, you believe that there's going to be a significant warm up, but you're also seeing some data points here in early and mid March that suggest to you that we could see more cold periods again.
Yeah.
So, okay. All right. All right. Well, I think I want to be respectful to everyone's time. So I think let's leave it there. That was a good place to end it. And thank you to everyone, in particular Dave Darkangelo, Nat Johnson, for all the helpful guidance here. I think it was a great discussion. So thank you very much, and hopefully we'll see you guys next week.
Thank you.
Thank you.
All right,
Thanks.
bye guys.
Thanks. Bye.
Bye.
Bye.